Hey guys, I'm Tim. I'm going to give you a quick walkthrough of my SQL Server UK postcode distance calculator. This is the GitHub repo. I will post a link to it in the video description down below. If you'd like to download it, the easiest way to do that, if you just click on code, and you can either open with GitHub Desktop if you have GitHub Desktop installed. Otherwise, you can just download a zip file, and this will download all the entire repo as a zip file to your downloads folder. All right, so I've got this already set up on my local PC, so you can query it and use it either in Azure Data Studio or SQL Server Management Studio. I'm going to use Management Studio today. Right. So, the essentially the purpose of this repo is to calculate the distance in kilometers between two postcodes. There are APIs, but that's supplied by Google that can do this, but obviously those cost money. And this is entirely free and it doesn't cost anything. Right. So if I flipping over to Management Studio. So the first function I'm going to show you is distance between two postcodes, and this function takes two parameters, just literally being two postcodes, and what it does, it calculates and returns the distance as the crow flies between these two functions in kilometers. So if I'm just going to execute that now, and we can see, right, so this SW1A0AA, that's the postcode of Buckingham Palace, and SE10 0DX, that is the O2 in East London. And we can see there's about 8.8 kilometers between these two postcodes. So if you let's say, for example, if you have a database and you're trying to calculate maybe your carbon footprint of all your employees, and you want to calculate how far they roughly travel, you can use the employee's home postcode location and their work location to calculate the distance, and then using that distance you can possibly calculate their carbon footprint. All right, so moving on to the next function. This is a table function as opposed to a scalar one. What this does, postcodes within X kilometers, this returns a list of all postcodes within a particular distance from another postcode. So it takes two parameters, the first being a postcode and the second being a distance in kilometers. So again, I'm looking at SW1A, the postcode of Buckingham Palace, and I'm saying return to me all postcodes within 1 kilometer. And that's what it's done. So this is a list of all postcodes within 1 kilometer. And what you could use this for, let's say you have a number of physical branches within the UK and you wanted to contact all customers maybe within a certain distance, maybe 5 kilometers within a branch to say, hey, this your local branch is running a promotion, come see us and get a discount. And so what you can do, you can get a list of all postcodes within the certain number of kilometers, and then you can use this list of postcodes and cross-reference that against the addresses of all your customers. So you have a list of customers that you can contact to let them know that their local branch is having a promotion. Right, so the third function I have for you is, again, it's another table function. This calculates the distance to all postcodes in the UK from a particular postcode. So again, we're using SW1A0AA, and we calculate the distance to every single postcode. So the first one returned is AB, which I think is Aberdeen. So it looks like it's about 641 kilometers from Buckingham Palace to Aberdeen. And what this might be useful for, if you let's say you found a customer and you're trying to ascertain their closest branch. I actually have an example on my GitHub page. So here this is actually using the cross apply um, join function. And what this does, it's let's say we've got a CRM database with a list of prospect clients, and we are using this distance to all postcodes function, and we're joining this on to our list of branches. So what this can do is say, right, so for this particular client, Acme Corp Limited, we've got a number of branches, and it calculates the distance from each the client to each of our branches. So let's say we're trying to find out, hey, what's the closest branch to this client, and we'll get that branch to get in touch with them. So Acme Corp is 7.4 kilometers from Brighton, it's 82 kilometers from Chichester, and it's 86 kilometers from Chiswick. So looking at that, it seems Brighton is the closest branch. So if the customer had a general query, say, hey, we'll get in touch with the Brighton branch and say, hey, talk to this customer since you're the closest one to them. All right, so that's, I mean, these are the three basic functions. What I'll do now, I'll just quickly show you the Visual Studio solution and tell you how it works. Um, Firstly, there is a UK postcodes CSV file here, and this is information that's publicly available in the public domain. You can find it on the internet by googling. And what this does is a list of all postcodes in the UK and the latitude and longitude of that postcode. So what we then do, okay, so I've got another function which I haven't shown you yet. This function's distance lat long in kilometers. It calculates the distance in kilometers between two sets of latitude and longitude coordinates. And the way it effectively does that, it uses a special haversine formula that converts the latitude and longitude to a angular distance in radians between those two points on the surface of the Earth. So if you imagine if we had 2 points in the UK and we drew a line from those points on the Earth's surface to the center of the Earth, and then we calculated the distance between the angular distance in radians between the two, we can then times that angle by the Earth's radius to get the distance in kilometers along the Earth's surface. So the Earth's radius is obviously just over 6,000 kilometers, timesing it by that angular distance, and we get the surface distance in kilometers. All right. Um, Cool. So let's close that and we'll open up just between two postcodes. So this is the most simple implementation of that calculation. So what we're doing here, distance between two postcodes, is just taking the two postcodes as parameters. It then looks up the latitude and the longitude of those two postcodes that we've imported into our database, and it uses the distance, latitude, longitude in kilometers to calculate the distance and returns that. Simple as that. Close that and look at the postcodes within X kilometers. This is making use of that distance between postcodes formula we just looked at, and it's a table function rather than a scalar one, so it's going to return a table just containing a list of postcodes, and all we're doing is calculating the distance between postcodes of every postcode in the table and the postcode that we've input as a parameter, and we've got a criterion, this where statement, saying where the distance between these two postcodes is less than the distance that we've input as a parameter, and it appends that to the table that we're going to output. All right, close that. And the last one is distance to all postcodes, and this simply returns again, it's returning a table, so it's returning a list of postcodes and the distance to those postcodes from the postcode we've input as a parameter. And there it is. This is a select statement. So that's the postcode and the distance calculated from our input postcode parameter and this listed postcode here. And then it returns the table. All right. I hope that makes sense. It's obviously not a database designed to be used on its own. You'll use it in conjunction with a CRM database, so you can pull out certain clients and calculate distances between clients and branches and anything like that. Again, I'll put the link to the GitHub in the video description below, and I'll put a link to my LinkedIn profile if you want to add me. That would be great. Thank you very much for watching.